Next.js has taken data fetching to the next level, making it even more efficient and developer friendly. Whether you're fetching data from the server or the client side, Next.js gives you powerful tools to optimize performance. In this video, I'll walk you through everything you need to know about data fetching in Next.js 15. Before we jump into code, let's quickly understand how data fetching works in Next.js 15. Next.js provides three main ways to fetch data. The first one is server-side fetching. This runs on the server before sending a response. Client-side fetching. This fetches data after the page has loaded in the browser. And static fetching. This fetches data at build time and serves a pre-built page to the user. Let's start by talking about server-side data fetching. So you can fetch data in server components using two methods, the fetch API or an ORM or a database. So for the sake of our examples today, we're only going to be focused on the fetch API, but I will be providing links to documentation on how to do it through a database or ORM. Next.js extends the native web fetch API to allow each request on the server to set its own caching and revalidation semantics. We'll go more in depth on caching in a later video, so make sure you subscribe to get that notification when that video does drop. Let's take a look at how we can utilize the fetch API in one of our server components to fetch some data that we need for a page. So let's talk about the example that we have on the screen. So you can see here we have a rendered output, which is just a post page that shows a list of posts to the user, and it also allows users to click on and be redirected to whatever post page or post item that we click on for more details. So let's talk about how we got here from the code base. To begin, we started by defining a new directory inside of our app router called post. And remember, to make our page accessible in the URL, we have to define a page.tsx file. So coming into our page.tsx file, we started by defining a helper method up top called getPost. This method simply calls the JSON placeholder API for us and returns that data as a promise. So we're using the native fetch API here, and by default, this is going to be a GET request unless we specify otherwise in the options. We'll talk more about that later as needed. So this is all getPost does. It calls our JSON placeholder API and it returns a promise. So a few things to note here. Remember, this is a server component by default because we did not specify it by using a use client directive at the top of our page. So moving on to the actual post page component itself, you see that we actually marked it as async. Why did we mark it as async? Well, we're using an asynchronous method inside of our post page component now to fetch post. So we're using the await method. So in order to use the await method, you have to mark your component as async. So after we fetch our post, we actually defined a new type. So let's go ahead and look into this. So we defined a new type to basically define what our object should look like that we're getting back from our JSON placeholder API. This is a relatively simple object, ID, title, body, user ID. So inside of our post page component, after we fetch the data and get that promise back, we're saying we're expecting it to be an array of posts. So this is basically all we're doing here. Again, this is just TypeScript. It helps things be cleaner. Helps other developers in your code understand what's going on too as well as they develop. So after we fetch the data, we take the data that we got and we loop through it or map through it using the map function. And then we just we keep rendering different links. So in this case, we take the post ID and then we show the title and we show the body, which is what we got on our output here. So this is how you fetch data in your server components and actually use it to render an output to the user. In programming, memoization is an optimization technique that makes applications more efficient by storing the computation results in the cache and retrieving that same data from the cache the next time it's needed instead of computing it again. Basically, working smarter, not harder. A really awesome feature of Next.js is that it extends the fetch API to automatically memoize requests that have the same URL and options. So what does this mean for our requests? This means that we are able to call a fetch function for the same data in multiple places in the React component tree while only executing it once. Instead of fetching data at the top of our component tree and trying to pass it down to each component, we can fetch data in our components that need it without worrying about the performance implications of making multiple requests for the same data. Let's take a look at how request memoization works with a quick example in our code and with a helpful diagram. So on the right side, you can see that the Next.js site has a really helpful visual of how request memoization works. So let's go ahead and just start from the top. So for example, in our code, we have a post page that renders details about a given post based on a supplied ID. This is a dynamic route. If you aren't familiar with dynamic routes in Next.js, be sure to check out the video that I made a while back on those. So this is a dynamic route that renders a page for a given post based on a supplied URL. So inside of this page, you have a function called getPost. This function takes in an ID, like we talked about, that is going to be supplied from the URL. And then inside of this function, we simply have a fetch request to JSON placeholder to get a post by its given ID. If the post isn't found, we throw a not found error, but in this case, it won't be because we know we're doing it for test data. So inside of this page, the getPost function is called 2 times. So we have the declaration and we see it's called once in generate metadata. And then it's at another time it's called on the actual page itself. So how request memoization works. So while rendering our route, in this case, our dynamic post page route, the first time that we attempt to call the getPost function, the result would not be in memory. So it just checks to say, hey, have I done this before? No. All right. So I'm going to go ahead and go getPost from the actual API. This will be a cache miss. You can see we have it notated here, and you can see it here in the picture in the documentation. So first time cache miss because it's not existent yet. We haven't done it yet. So it makes sense, right? So moving on, after we've done this and we continue on through our render process for our given route, we try to call the getPost function again. So this time we ask ourselves the same question. Hey, have I done this before? In this case, I already have done this. So that means that this data already exists in my cache. So I don't have to do as much work. So that means I'm just going to go ahead and grab this data from the cache and again, use that same data there. So in this case, it'll be a cache hit. You can see here we have it notated here. And then you can see that follow along with the diagram as well. So after any other calls that we make to the getPost function during this render process will be a cache hit, because again, we've already hit it the first time. So during this render process, any other times that we hit this, so if we have like a nested component that calls this getPost function or calls the same URL, it'll be a cache hit because we've already done it. So once the route has been fully rendered and the rendering pass is complete, our memory will be reset and all request memoization entries are cleared. So again, this only happens during rendering. Of course, you can always add cache into your API requests throughout the application, but that's a whole different topic for a different video. So this is how request memoization works in Next.js. When fetching data inside components, there are 2 data fetching patterns to know about: parallel and sequential. Sequential data fetching occurs when you have requests in a component tree that are dependent on each other. Note, this can lead to longer loading times. So if you have nested components and each component fetches its own data, then data fetching will happen sequentially if those data requests are not memoized. However, there may be cases where you want this pattern because one fetch depends on the result of the other. So for example, on our post page, right here, if we wanted to render comments for a given post, our comments component down here will not be able to render until the post component has finished fetching the data for the actual post itself, since comments depend on the post ID. In this case, we're using the React suspense boundary to show an instant loading state while React fetches the result or streams the result. This will prevent the whole route from being blocked by data requests, and the user will still be able to interact with the parts of the page that are ready. Parallel data fetching occurs when requests in the route are eagerly initiated and will load data at the same time. This reduces the total time it takes to load data. To fetch data in parallel, you can eagerly initiate requests by defining them outside the components that use the data. This saves time by initiating both requests in parallel. However, the users won't see the render result until both promises are resolved. So for example, we have a user page. On this user detail page, we're going to be displaying user details, of course, and albums made by that user. So we have 2 functions, getUser, which fetches the user detail, and getUserAlbum, which fetches albums made by that user. So both of these functions take in an ID, And inside of our actual page component, we make calls to both of these, but instead of awaiting both of these separately, we're just going to await a singular promise by using the promise.all. So users will not be able to see any data until both of these promises complete. And that is how we would initiate or set up parallel data fetching on our page. The recommended approach is to fetch data in your server components first, but there are still cases where client-side data fetching may make more sense. In these scenarios, you can manually call fetch in a use effect or lean on popular React libraries in the community such as SWR or React Query for client-side data fetching. Let's take a look at how to fetch data in the client component using the fetch API. So moving back to our code, you can see that we've created a new route in our app router called client, and inside of that directory, we created a new directory called post. So this URL will be accessible through localhost 3000/client/post. Just a good way to separate our client code for this example. So in this example, we've declared a new component using the use client directive. So this is no longer a server component, it's a client component. And inside of it, we've declared a use effect hook. And inside of the use effect hook, we've made an async function called fetch post. This fetch post function does the same thing that we were doing on our original post page, which is just calling JSON placeholder for some post. So we're using the use state variables, and we're just setting that value inside of our use effect hook. And we're saying if there are no posts, show the loading state. When posts are loaded, go ahead and render things out to the user. It's generally not recommended to use this method when you're trying to fetch data on the client side, but it can be done using the fetch API. It's nothing breaking, but it's just generally not recommended. They typically recommend that you use the third-party libraries that we talked about earlier, SWR, React Query, Axios, all that fun stuff. While we won't be covering how to fetch data on the client side using those third-party libraries, if you're interested in me making videos on that, let me know in the comments and we can make it happen. With the recent release of React 19, we were introduced to a new method changing how developers handle asynchronous operations like data fetching and context consumption. Use is a React API, not a hook, that lets you read the value of a resource like a promise or context. Unlike React hooks, use can be called within loops or conditional statements like if. Like React hooks, the function that calls use must be a component or a hook. Here's what you need to know about the use API in React 19. The use API must be called inside of a component or a hook. The use API takes one parameter, resource. This is the source of the data you want to read a value from. It can be a promise or a context. When fetching data in a server component, it's recommended to take advantage of async await over the use API. Async await pickup rendering from the point where await was invoked, whereas the use API re-renders the component after the data is resolved. When creating promises, you should create them in server components and then pass them to your client components instead of just creating promises in your client components. Promises created in client components are recreated on every render. Promises passed down from server components are stable across re-renders. Now that we have a decent understanding of the use API, let's use it. Okay, so let's hop into an example of us using the use API. So in this current example, we're taking advantage of the API to stream data from the server to the client. We started by fetching data in our server component, using the same get post method to fetch some posts from JSON placeholder, and we passed that promise to our client component. So notice we did not await our promise from get post, since the use API in our child component will be handling that. So we no longer had to make our page component async, and we no longer awaited the get post because the use API takes a promise as a parameter. So now if we go into our post component, you can see we're actually calling the use API. Our component is marked as a client component, and all we're doing is saying constant all posts is equal to use post, because our parameter post is going to be a promise of an array of posts. And just like how we did before, we're just mapping through our response object and displaying a title to the user. So that is a really quick example of how we can take advantage of the use API method of React 19 to stream data from our server components to our client components. And because our component is wrapped in the suspense boundary down here, The fallback will be displayed until the promise finishes doing what it has to do and resolving. Static rendering means that routes are rendered at build time or in the background after data revalidation. So what does this mean? It's useful for when you have routes that has data that's not personalized to your users and can be known at build time, such as blog posts or product pages. A good example of how static rendering will work in our code base is coming back to our original post page. We have this function here, generate static params. What does this do? So it can be used in combination with dynamic route segments. In this case, we are on a dynamic route segment to statically generate routes at build time instead of on demand at request time. So in this case, since none of this data is user personalized, our post in this case, we can go ahead and statically render or get these things pre-built while we're building our app instead of having them be requested by the user whenever they visit the actual page. So all we're doing here is calling the JSON placeholder API via the fetch method. And then we're just saying here, we only want to pre-render 10 of them because this API returns 100, but in your use case, you can do whatever. I'm just chopping it down to the first 10. So whenever you run the next build command from your terminal or your command line, it will pre-build the first 10 post pages of your application. So this is really useful and it really helps optimize your application for data that doesn't change that often. Next.js offers multiple data fetching strategies. Taking advantage of these options will help you build highly optimized Next.js applications. If you found this tutorial helpful, drop a like, subscribe, and let me know in the comments which data fetching method you use the most. And see you in the next one, and happy coding, y'all. Peace out.